Cool. 518 coin change 2. You're given coins of a different denominations and the total amount of money. Write a function to compute the number of combinations that may make up that amount. You may assume that you have infinite number of each kind of coin. Okay, cool. Uh, okay, I mean, I know. So it's, essentially, I mean, this is actually very similar to the first problem we did of the day, where, or maybe the second, the one that looks like a Fibonacci number. But basically, given coins, like let's say this one, then f of n is just equal to f of n minus 1 plus f of n minus 2, f of n minus 2 plus f of n minus, oh, shoot, n minus 5, right? So that's how, and that's pretty much it, right? So you kind of do that for all these and then you count it up. Yeah, I mean, so it's very similar. You just have to go through it. Yeah. Um, yeah. Okay. Uh, anyone have questions before I start? I guess I'm just gonna start then. Um, I'm at, so f of 0 is equal to 1, and that's it. For that's a range amount plus 1 for coin and coins. F of a is f of a minus coin. That's right. And just return f of amount. There's a quick change. I had to fix bound checking. I think that's it. If a minus coin is 0. Oh man, I did this. Is that right? I do this in the wrong order. One way, two ways. I'm looking at the way, right? 2, 1, was it 1, 2, 5, 1, 2, 5? Well, I'll pass over. It looks okay. 0, 1, 1, 2, 3. So how many ways are there to do? Man, I'm really rusty. If I'm having trouble with this one. So 1 is equal to 1, 2 is 2 because there's 1 plus 1 and 2, 2. So 3 is equal to 4 is equal to is 4. I got something backwards. Maybe I got something backwards. Oh, okay. I think I did it in a way that was order dependent. That's why. Okay. So in that case, or order not order dependent. Okay, so that's where it actually differs a little bit. You're right. So then that means we only use the same coin once. So I think you just have to loop a little bit the other way. Yeah, is this right? I think this is right. Yeah, okay. Cool. Okay, I missed some like at 0 case type thing. Okay, cool. How do I feel about this? I think some of that is that I have experience with this problem, so that's why I'm able to adapt that quickly. And fun fact is that I think this was probably like 15 years ago or something like that. I actually wrote an article on coin change tutorial thing, and that got I think someone copy and pasted into Wikipedia at some point, so you could say that I mean, I think they've cleaned it up and changed a lot since then because that was 15 years ago. But so I was playing around with this farm a lot back in the day. I think the way I would go about it is I think what I did, there were a lot of optimizations that I made that are not apparent because which is why, how do I want to talk about this? Because you could also rewrite this as, and maybe that's what I like. I'm not going to change this into readable code, but you can also imagine, I don't know, something like coin index. Let me paste this somewhere so I have a version of this somewhere. Hang on. But yeah, you would imagine you have like coin index, something like this. And your array now will be coin index -1, and then I don't know, last coin index, which is coins -1, something like this, right? Yeah, so I think people write it out into one DOA, and that's certainly obviously what I did. But that's not, I think that's an optimization that people do a little, I mean, just because people have experience with that optimization. And me, and to be honest, I'm not even trying to flex or whatever people are saying, but like there's something that I did innately without really thinking about it until I got it wrong and try to explain why that to people, how that came up. But I think this makes it slightly clearer. So this is telling you this using no coins, and there's only one way to get to from no coins, and the sum being 0, right? And then here, it's just that we want to make sure that, and if you do it this way, maybe the for loops doesn't really matter, the for loop order maybe, but the observation here is noting that you're only gonna, because you're counting your for loop from smaller to higher, so essentially you're doing things in place almost, and that's why you're able to get away with it with 1D, because this is always referencing a number that's smaller than A, and the previous array, right? So yeah, and you do it recursively. Like let's say you do it recursively. Uh, I could look at coin change one too, but coin change one as well. But but yeah, so I can imagine like your recursion could be like, let's say I'm just gonna rewrite it because I think this is maybe worth learning a little bit and me learning how to explain it a little bit. Let's say you return count of um, let's say you want to count the amount with all your coins, right? Well, at least all of your coins processed. So then your count function would be something like I'll do more. Oh man, minimum score tracking. Oh my, that already sounds like a mouthful. but but yeah, you could imagine writing this as something like okay, and I'm hand waving a little bit because I don't know. But you look at well, how many times can we use coin sub n? Let's just call this index. An index. And then you have a for loop, right? Which is well, one time. Well, now I'm writing in another language, but for I in exchange from well, let's do a while loop, right? While or sum is less than amount or less than equal than amount. You sum up. Okay, total count is equal to 0, and your total count is equal to count of amount minus sum, and then coin index minus 1 or something like that, right? And what this is saying is, oh, oops, I didn't, and then sum coins, like something like that. I mean, I'm not cleaning this up now, but if you look at something like this, then you, yeah, it doesn't really matter your for loop, but you could see how this works out. Actually, maybe this is not even just a little off because you can do things. You could go to amounts that are off by. Yeah, okay. So, for example, for what did I do? What am I doing? Oh yeah, no, I think this is right. Yeah. And this way, because you move the coin index, you never use the same coin more than once, or you never double count it later on again. And then this goes 0, and then your base case is just if amount is equal to 0 and coin index is equal to 0, or maybe -1, something like that, and you don't know. And then, so that's kind of the pseudocode for how I would write this, and then memorize it afterwards. Yeah. But yeah, I think coin change is a very standard problem in Dyn program, for better or for worse. So definitely read up on it. It's the first example of what people call pseudo polynomial, because it's polynomial in, let's say k is the amount and n is the number of coins, then it runs in k times n times, where k is, not the size of the input. So it's just a number representing the input. And for knapsacky stuff, I think it's the best you can do with limitations. But don't quote me on that. We repeater. But it just come up maybe not necessarily knapsack per se, but pseudo polynomial dynamic programming problems does come up pretty often. So it's something that I recommend. And also, as a side note, because of how you think about these estates, it comes up sometimes during how you want to set up deep learning neural networks as well. So, so definitely something to study up about. But yeah, this is a very standard interview problem, so that's what I'm going to say about it, because it is standard, so I would expect to kind of experience this. So yeah, okay, cool. Did I